Hi, welcome to today's session on gradients of linear graphs or linear lines. So when we're talking about the gradient, we are talking about the slope. We're talking about the steepness of the line. So here's our basic line equation. So we've got y equals mx plus c, and the m here is the gradients that we're looking for. So when we're talking about the gradient, we're looking to try and calculate what number is meant to be going here. So here I've gone and created my line on my 4-quadrant graph, and this is actually the gradient. Sorry, this actual line is actually made up of y equals 2x plus 1. We're just going to actually show how we can find this number 2, and then also how we can find this plus 1. So we are going to use this formula for calculating the gradient. So m equals the height divided by the length. Now, to find this, we need to pick 2 points on our line. So here I've gone and pick this point up here and this point here. I've only picked up these points because they are on in the middle of the squares, in which case it will give me full numbers as part of my calculation. So the length going along the x-axis, so I'm going along 1, 2, 3 until I'm in line with the other coordinates that I've chose, and then the height 1, 2, 3, 4, 5, 6, in which case 6 is going to be my height. So I've created a triangle on my my line with the length and with the height. So now I've gone and substituted these values into my formula. So m equals 6 divided by 3, which equals 2. And we was expecting this because 2 is in front of the x. But we would not normally be given this. We would be asked to calculate this. So immediately what we'd have to write is y equals 2x plus c. Now you might be able to identify c straight away from the graph, because the plus c will be the y-intercept. But we could also calculate this and show it as part of the working out. So choosing a coordinate, I've chosen my 0, 1. Even though we know that this will end up being plus 1 at the end, we're just showing exactly how we can use this. I've substituted my value in for y, which is my 1, and my value in for x, which is 0. So 1 equals 2 times 0 plus c. So 2 times 0 is 0, so I'm left with c equals 1. So my end result would end up being 2x, y equals 2x plus 1. Again, this is what we was expecting, but just using this to confirm that we've got the correct answer. But just showing that we could also use this method to find negative lines. So here I've got a line that's not going up in a positive direction, it's going in a negative direction, and we can still use this to calculate. So I've picked 2 points on here. As you can see, this time I haven't given the line equation. We're just going to use this to calculate. So I've picked this point here, this coordinate here on the line, and this coordinate here on the line. So this time I'm going to the left, counting to the left. So if I was counting to the right, just like our numbers, I'm going positively. If I'm counting to the left, I'm counting negatively. So I've got -1, -2, -3, -4, -5, and then the height goes up by 8. Putting that into our equation here, m equals 8 over -5, so this is just going to be -8 over 5 as a fraction. We could work that out as a decimal if we wanted, but when it comes to line equations, it's just easier just to leave it in fraction form. So now I'm going to put this into my line equation. So y equals -8 over 3x plus some constant. But as you can see here, we can't identify for definite where this line crosses the y-axis. So for this one, I'm going to be calculating it. So I am choosing the gradient, the coordinate of 2, minus 1, which is on the line, just here, which was actually one of the points that I chose, and substituting this into my line equation. So where I've got y, I've now replaced that with -1, and where I've got x, I've replaced that with 2. I've substituted it. So 2 times minus 8 over 5 is negative 16 over 5. Now if I was to add 16 over 5 to both sides, or move this from the right hand side to the left hand side, it will change from a negative to a positive if we took it over to the left hand side. So I've got -1 plus 16 over 5 equals c, which becomes 11 over 5 equals c. So putting this back into our line equation, we got y equals negative 8 over 5x plus 11 over 5. And that is our end solution for calculating our line equation through calculating our gradients. If you like what you see, please subscribe. Thank you very much for watching.